Hello everybody, ready to show off a few more things. As the title suggests, this video is going to be mostly about emitters and shaders. But before I get to any of that, I thought it would be good to do just to mention a couple of other things that have improved, even if I won't really be showing them. In previous videos I showed off the collisions and the state machine. Both of them have been improved in the meantime. Collisions, the output of the collision system is still the same as it was before. So in a sense, that one hasn't really changed, but behind the scenes, I cleaned it up a lot. It's a little bit faster as well, but the main thing is that it's much cleaner and easier to understand, which means that if I need to make changes to it or improvements, it's going to be much easier going forward. So it's kind of like the first step towards making improvements there, or just allowing myself to make changes if necessary. So that's a nice thing. Most of the other improvements come from the state machine side of things, though, where the biggest one being, in previous videos I mentioned that I wanted to get the player character and the enemies to all use the same system. So if you haven't seen that video, basically I showed off how I have this state machine thing set up where it's data driven, so I type in a few things that I want this state to be, and I can make the character do all kinds of things, like I can make their animation oscillate, or I can make them move at a certain rate, and all of this can be tied to curves so that they can get nice smooth movement or interesting effects based on how the curve looks and all that kind of stuff. We can delay our slide for a frame or two by having the curve just work that way, right? Things like that. And that's done. So I won't get into all the details, but basically the player character and enemies now have a shared parent, which I've called actor. So they're both considered to be actors, and actors are the ones who do these kinds of things. And by the way, if you're curious about what's going on, I still have Victor under the hood here, but I've hidden him behind a shader, which just makes him into a square. So, and this isn't his bounding box, it's the full size of his sprite, which includes the transparent parts. The parts that are normally transparent are being drawn blue here. You can kind of see him moving up and down. That's because he's breathing under there. So yeah, so that's good now. That you won't see any of them in this video, but I've tried out a couple of enemy characters, and it seems pretty easy to get them up and running, and they can do all sorts of stuff, and they animate properly and all that kind of stuff as well, you know, which is nice. There's also been a couple of extra little features added, like one thing which it's going to seem minor when I show it here, and it kind of is minor, but I have a collision response thing now. Previously, when you collided with terrain, so this is separate from the thing I showed off before where, remember, I vaulted into a candle and I did a backflip, right? So that's great, that's already in there. But this one is kind of about collisions with terrain, what we want to happen to our speed when we hit terrain. So imagine this is an uppercut, because it is, right? And again, I just want to point out that's not his bounding box. His bounding box is not going into the thing. It's just that the uppercut sprite has remember, it has a thing that goes into the tile, right? I just thought I should hide him for this video because he's not really the focus, right? So normally, like if we uppercut into a ceiling, what was happening before was we immediately lost all our speed, whereas now, and I've made it so the uppercut can cancel itself. So if I just spam the uppercut button or just tap it every once in a while, you'll see that we keep our speed. So we can set a couple of different options, like lose speed, maintain speed, reverse speed even, so we bounce off stuff. And that's done now at the state level. It's part of the state machine, all that kind of stuff. And of course, there's a whole bunch of other little fixes and improvements made along the way. Too many to list. One example is, I didn't really want animations to be able to cancel themselves, but I decided to fix up a problem with that where they weren't animating correctly if they did, just in case we ever need it or whatever. Or it kind of relates to something that I said on a stream recently where I was talking about how we want the player character to be able to move from one state to another, because what frame we want to be on screen. I'm not going to get back into it, but basically there's been a significant bug fix there and stuff as well, and a bunch of other stuff. But today we're going to focus on emitters and shaders, so let's get into those instead, okay? Here we go. Alright, here's a bunch of emitters I've set up. As you can see, they do a bunch of different things. I'll talk about each one individually briefly. I just want to point out that most of these are using a single pixel. Now that gets scaled up to several pixels. I'll talk about that in a while. Most of these are just using a little square, you know, as their sprite. So you're going to have to use your imagination here a little bit, because they won't all necessarily be that way in a final game. We might want to actually assign sprites to them. One example of that would be this one here, which these are some little kind of ancient language sprites that I just mocked up in about 2 minutes, so don't read too much into them, right? They're just little squares. They kind of look like the Infinifactory font. Anyway, this effect is kind of like how I imagine something like the barriers in Okami, which have the kanji characters on them, you know? So we can use sprites for these particles. All of these particles are sprites. There's really no difference between them, right? It just happens to be a sprite, which is very small and just a little pixel in most cases. But we can change that if we want to, right? So if an effect would be better served with a larger sprite or a sprite that does different things, we can have that too. But just for testing purposes, I just want to use these little sprites. And I actually think they look pretty good because the game is pixelated anyway. I'll talk about that again in a little bit. Let's just talk about the actual emitters for now. So one thing to keep in mind is that emitters do not really interact, or particles do not really interact with the game world, right? The whole idea here is that we get nice complicated effects. The trade-off that's happening is we can get some nice complicated effects, but they're done entirely on the GPU, which does not have access to the tile data or anything like that. And it's not a general purpose computer. It's not, you know, it's not going to collide with stuff. Now we can kind of fake that and get around it in a couple of different ways. But point being, it's not going to interact with terrain and all that kind of stuff, right? But it means that in return, we can get lots of different effects on screen at once. We can do a lot of different stuff. But we can kind of fake these things to some extent. So I think this barrier here would be a good example, or this the thing up above me here, the green thing, which I imagine kind of looks like an energy bridge, kind of like Out of This World or Another World or Flashback or something. Kind of looks like a sci-fi energy bridge to me. So we can fake it. One thing to keep in mind is that all of the orange tiles you've been seeing so far will be invisible in the final product, right? So they're just not going to be there, which means that if we did want some kind of barrier, or, you know, we could have an object as well which blocked the player, like a door that maybe gets deleted once you've killed a boss or something, right? We can have that there and be invisible and just put these over it, so it's like the player is colliding with the particles. So there's actually, we can do some kind of interesting stuff with them that way. Likewise with the bridge, we could just put some orange tiles there and they won't show up, and it'll just look like the player is walking over the energy bridge, right? So a few things I want to point out. Some of these emitters are just for testing purposes, like the white next to the big rainbow ring. There's a white dot there that's just moving upwards. That's testing a pulse option that I have on my emitters, so they can, most of the time you want your emitter kind of firing randomly, doing random-ish sort of stuff, because that's the way things look in the real world, right? But we can use, I have a thing in here so that I can set a pulse kind of level, you know, what rate it should pulse at, and it'll do that evenly, so you can see those moving up an even interval. Likewise, I don't think the big rainbow ring is something that you would actually use in game, but it's just showing how the particle can blend between 3 different colors, right? Now, a lot of this stuff is, this is an area, emitters or particles more specifically, is an area where, of all the stuff I've done, it's probably the place where Game Maker is doing the most heavy lifting. And it's the place where you feel that trade, or I have felt that trade-off between using a predefined engine, a pre-existing engine, versus not, right? Because the upside is a lot of this stuff is very simple to implement, a lot of the particle behaviors, right? So most of the actual work that went into this is how the emitters work. So the emitter is kind of a separate thing from the particle, right? The particle is, if you look at the embers above my head here, the particle is the little red dot, and it's what it does. But the emitter is, you know, where do we want them? How rapidly do we want them? That kind of stuff, right? So most of the work that I had to do comes in on the emitter side, not on the actual particle side. And there's basically, Game Maker has some handles here that allow you to set various aspects of a particle up, and then of course you can just fire it whenever you want and get that particle out. As a result, it's very easy, but there's also some limitations on it that I'm not convinced need to be there. For example, you can set a particle to have a random speed. So these blue embers, which I kind of think of as futuristic embers, they're kind of like computer Tron embers or something like that. They come out blue at the bottom, and there's quite a variance on their speed there, more so than with the actual red embers here. There's a big variation in how fast they're moving. So some of them go up really high, and some of them are quite slow, right? So you can set that randomly, and then the emitter just fires them out at random speeds. But you can't do that with orientation. So you can't have a different spin on particles. You can't assign them a random spin within a certain range. I don't know if that's a Game Maker limitation or not. I don't know what the story is there. There is some kind of underlying, I think it's OpenGL or something. There's some kind of underlying protocol for all this stuff, I believe. Because I think that even though Game Maker, I think the options that you find in Game Maker are not going to be that different from the options you'll find in something else like Unity, apart from the fact that Unity will have an extra dimension and all that. But I don't know for sure. What I do know is that Game Maker does make it very easy to set up particles, right? And so a lot of this stuff is pretty simple, but getting the emitter to work and getting all the stuff I wanted on the emitter did take a little while. It's the kind of thing that would be easier if I knew what I was trying to get from the start, right? It's kind of fumbling my way there is kind of what cost me time on this one. But once you know how to do it, it's not that hard. Yeah, so bunch of different emitters here. I don't think I need to go through them all and explain what they are. But they are kind of, this is both a test room, and I'm thinking of it as a test room and a palette, right? So one thing to be aware of here is that all of these things that you see on screen here are the same object, right? They're the same. There's just a particle emitter. There's not 10 different types of particle emitter and you have to pick which one you want to get the desired effect, right? They're all just the same particle emitter, and they all just, in the level editor, they have different options on them where I put in different pieces of data. I type in, okay, I want the speed to be between 1 and 5, and I want the direction to be this way, and right? And then we get different results out the other end, right? So it's kind of, I'm not great with terms. I think this is the right term when I used it last time. It's kind of like the state machine, data driven, right? They're all the same thing, and it's just by plugging in different numbers that we get different effects out the end. So I think with that in mind, you can see how flexible they are, right? None of these things have custom code compared to each other. It's not like I went in and I wrote, okay, I'm going to write a ancient language barrier, right? And it's going to have to do all, and I'm going to write in 100 different lines of code to make it do that. It's all the same thing, right? Here we can see some raindrops. So there's a few different things at work here. These raindrops are an example of particle chain. Particles can create other particles randomly as they move through the air, or they can do it when they die. So there's actually two particles. This raindrop is two particles. There's one that moves slowly, and then there's another one where you can kind of imagine that it falls, right? So this is it. The first stage is it rolling down a surface, and then the second stage is it falls off the surface. So when it gets to the fall stage, then gravity takes over and it falls more rapidly as it moves towards the ground, and it's just moving faster in general, right? So that's a particle chain. And the cool thing about the emitters, the way I've set them up, is that the particle chain can be as long as we want. We can have as many as we want. And I'll show a little example of that later. I think the longest one I've actually set up is just 3 particles. But I should probably put it through its paces a bit more, but there's no reason why it shouldn't support many, many more. I don't foresee any issue there. Yeah, so the raindrop is an example of a kind of particle chain. The one above it is a pulse, like I said. Some of these are just effects that I found by messing around a little bit. These pink fly things, they kind of remind me of the nanomachines or nanites from axiom verge. You know, they kind of have that feel to them. There was just something that came about from messing with the variables. Likewise, the one above is very glitchy. It looks kind of like a glitch. That just came about from messing with the various options and seeing what came out the other end. It's been kind of cool to mess around with the emitters and just click on stuff and see the effect out the other end. Previously, you know, I've had some particles in before. I think they were in a previous video on the candles and stuff like that. And I was typing all this stuff in its own file, you know, but it's nice to be able to go into the level editor and just mess around there and then see the result pretty quickly once we load back up. So, yeah, so that's kind of some glitchiness up above and then a little swarm. More interesting, these two are a little bit more interesting actually, even though they may not look it. So the one directly above my head that looks kind of like cellular automata, it's showing a property and testing a property of these emitters, right? So by default, when I drag an emitter into the room, it takes up one tile, right? I've set it up so it's just the same as a tile. It just kind of looks like a little transparent tile that I can see in the room. But I can stretch them and move them around to cover whatever space I want. So all of these things are one tile, except this one here, which is stretched to fill the space between the tile here and the floor, right? So it's stretched to fill that space, and then its setting is just, you know, somewhere in this area spawn a particle that looks like that. Now this one is the same, except it takes up one tile, which is overlaid on the tile that you're seeing here, and it has offsets. So these are an important thing to be able to have for control. So you might notice the little blue dots. It might be hard to see in the video. You're probably going to want to watch this video at the max resolution if you can. So it might be hard to see in the video, but the little blue dots here, they never overlap with the white outline of the tile, right? Now that's just one tile, so they should be filling in that space, but they don't, because there's also an offset option which has been pushed in by one in each direction to get them to spawn just in that little space. So we're testing that little space to make sure it's very precise. You know, we never want to see anything outside of that. And as you can see, they're all behaving exactly as we expect. All the little dots are just in that area, which is nice. It also shows another thing, which is that if I walk in front of the rain, or this thing here, you can see my character obscures them, but these dots here, they're in the foreground. So we have two different layers. I can have multiple layers if I want. I've just set it up to have 2 layers for now and see how I get on with that, and only add another layer if it feels necessary. But there's 2 effects layers. There's a background and a foreground layer. So we can achieve different things by using the different layers. Above it is some sparks, and that shows the ability to spawn several particles in the exact same place. So when a spark fires, it's somewhere between, I think, 4 and 6 particles. They spawn in the same place, and it's just they're given slightly different properties which push them out in different directions. So yeah, so they all look like they're a single spark, you know, which is important if you want that kind of effect. This one's kind of an emergent one that I just came up with messing around as well, and it's actually still just a single pixel, but it's stretched up, so it's scaled up to be really long, and then it's just fired upwards, and it kind of gives this effect of a barrier, you know, so it looks like a barrier. And again, just like the other stuff, we could put some tiles there and have the player collide with it if we wanted to. There's no reason why we can't do that. These show the ability, I'll keep them off screen because they're a little bit distracting, but these 3 down the bottom here, the rings, are just showing the ability to get different kinds of circles if needs be. Not too much going on there, but that's not a given, because by default the particles spawn in an area, right? So this circular thing is actually achieved using a particle chain. But yeah, we can get many different kinds of circles here. Also, some of the particles, God, it's hard to go through all the options. There's all kinds of different options about where we spawn the particles. So for example, this one with just above me here with the line being drawn upwards, it's not being spawned in the box, right? It's being spawned at the top of the box. So we can set a line that we want to spawn it in. There's all kinds of different options we can use about where we want to spawn the particles. Likewise with these raindrops here, they're not spawning inside the tile. They're spawning at the bottom of the tile and falling down. And I've made this stuff pretty easy for myself, so I can select most of it just as an enumerator. I can just pick certain options, but we can always tweak it using the offsets as well. So this one does use the tile. Remember, these blue dots here, they do use the tile, but then they just have an offset. So we can kind of pick and choose, and we can, you know, we can get very finely detailed, you know, about where we want each particle to spawn using the offsets, or just the general options that I pick. The white thing up the top there, it's just something I was messing around with. These ones here, I know they look like crap, but they're just showing a smoke trail. It's surprisingly hard to get a smoke trail to look good. I've spent a lot of time messing around with a bunch of these particles, and the smoke trail is surprisingly annoying. But yeah, you can kind of see a little bit of a smoke trail coming off those things. They could look a lot better, and of course we could substitute that. You know, that projectile could be a sprite of its own, and the smoke trails could be a sprite of their own. So we can substitute all that as needs be, but just for messing around here, it's fine to use a single pixel, I think. Okay, so now we have a few more weird ones here. The purple thing up above me here is again showing a particle trail. It's creating that nice sort of cascade of colors by having a brighter color, which creates a trail of darker colors behind it, and you get that nice pattern. It's kind of interesting looking. This is also a particle trail here, this green thing, just creating a little curtain. Again, it's not really that interesting in terms of what's going on as a particle, but I think the effect is interesting. It's that kind of diamond shape, so I wanted to keep it saved in my palette in case, you know, I wanted it. And, you know, I can mess around with the gravity on the particles and get them to do different things. It's also showing how precisely we can aim stuff. So if you see the white thing coming out of the top right or the top left corner of this box is going into the top right corner of that box. So we can fine tune the aim of stuff very precisely if we want to. Up above it, the yellow ones, which are kind of being overshadowed by everything else on screen, right? But the yellow ones are actually very interesting. You can see they're creating a kind of U-bend there. And what's going on is, again, you might not be able to see it in the video very clearly, but you can actually trace a single particle from the left and watch it flow over to the right in one unbroken movement, right? Now, that's not a given, right? This is the kind of thing which it seems like it should be simple, but it's not necessarily, right? And you've decided to watch a video about development, so I'm gonna spoil some of the magic here for you. If you don't want to, you might want to turn the sound off for a minute if you don't want to hear. Behind the scenes, it's not actually one particle, right? It's kind of like the teleporter on Mars experiment, right? Is it a clone, or is it, you know, For my money, I think if you take the teleporter to Mars, you're dead, right? There's actually 3 particles here. So what's happening is, on the left side, there's a particle being spawned which is moving directly upwards. Then, once it reaches the end of its life, it spawns a clone which is identical in every way except that it has a turn to it, right? Then, once the turn is complete, its lifetime is over, and it spawns another one which is identical in every way except its direction is just straight down, right? So, it looks like a single particle, but if you were to examine the data, you would see that it's actually 3 different particles working in unison that look like one particle. But you can get into a whole philosophical debate about whether, like, from a human perspective, from our perspective, doesn't really matter, right? Because it looks like one particle. The only way that we interact with a game is by the input on the controller or the audio-visual stuff coming back out at us. So in a sense, it doesn't really matter. And that's the effect that we've achieved, is it looks like a single particle moving around, but it's actually 3 different particles. But it goes to show that we can have an arbitrary chain. We can move in arbitrary ways. We can get a different kind of bend. If, say, we had a pipe flowing through a level and we wanted some bubbles going through it in the background, you know, we can get them to flow through the pipe, no problem, by using a chain of particles that just start at the start and move their way to the end, right? So you have to use your imagination a little bit about how we can use these things. Although some of them I quite like as they are. Like I'm weirdly drawn to this green ring. I think it's really cool. And I quite like the sparks as they are, and I think the embers are pretty cool already. You know, there's things that I like about them. But if you use your imagination, you can see how they can be even better, right? That if you imagine those yellow things are bubbles, and we have some sprites there that look like a tunnel, you know, and it's blue, then all of a sudden now we have a pipe with a bunch of liquid flowing through it, right? So that's pretty cool. There's a couple more effects here. That wheel of color over on the right is just it's almost like the one on the left, the white one on the left there, except that it's not spawning in a specific point. So that's another thing to keep in mind. The white wheel up here, it's not, see, some of the particles are spawning in a line or in a box. This one is just spawning in one point, the center of that tile, right? So we can do points, we can do lines, we can do areas, and by chaining particles we can do circles. All kinds of different things we can do. There's a couple more effects here. These arrows are showing how I also, on top of having pulses, I have a kind of a way of doing pulse offsets, so that these all have the same, I don't know what the term is, phase maybe. They all have the same phase, but they're all offset a little bit, so they're at different points of that phase, which gives you that look of the arrow moving to the right and then down. You see it going like that, right? This one here, this little crosshair, is again using pulses to a nice effect, where it kind of looks like a single thing just jumping around. You could kind of imagine it on a computer monitor, you know, in the background at some level. You've got a monitor and it's like showing things to someone, you know, bop, 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 jumping around. So it looks like it's just one particle jumping around in that space between the tile here and the ground. Now, one thing you may have noticed if you were paying attention, if I walk left here, and I don't even have to be running, if I walk left here, watch the rainbow ring. See how you actually, when I walked into this room in the beginning, it was in the same state. See how it has to actually fill in over time, right? This highlights a property, a kind of an emergent property of emitters and particles, which I think of as equilibrium, right? So depending on how long each particle sticks around, it takes a while for an emitter to reach equilibrium, right? And what I mean by that is there comes some point in an emitter's lifespan where, say, those yellow particles on top, right? If we took a screenshot right now, there's really no way of knowing whether that emitter has been running for 10 seconds or 100 years, right? There's just no way. I mean, assuming sufficient randomness and all that you can't reverse engineer the randomness of the game or whatever, right? There's really no way of knowing. So that's the point where it's reached equilibrium, where the thing we care about as a player or as a designer is where it looks like the particle emitter has been emitting stuff the whole time, where it looks like it's been active the whole time. And as you can see with the rainbow ring here on the left, that's not true. It's switched itself off, right? All of these emitters are switching themselves off when they go off screen. But just like how we need fine control over how, you know, where the particles spawn, we also need fine control over when they activate or deactivate. So by default, an emitter, it's just an arbitrary number, but I'll show you here on this. These two boxes here on the right are set up as a demonstration, right? So the rain you've seen before, I won't dwell on it too long. There's also some rain splashes down the bottom, which are kind of like the sparks. They're spawning several particles in one place that look like a splash on the ground, right? But these two boxes are identical in every way, except that they have different activation offsets, right? So the bottom one, as soon as it goes off screen, it switches off. And the top one will remain active for a while. It'll remain active as long as we're within 8 tiles, as long as the camera is within 8 tiles of seeing it. So that's the default setting. If we're within 8 tiles of seeing this emitter, switch on. So we look like we've been on the whole time, right? Now, the one on the bottom has been switched off. So if I move over to the right, see how it has to fill in. Whereas the one on the top was already filled in because it already hit its state of equilibrium. It was still in its equilibrium state, so you couldn't, you know, it was just on. But this one down the bottom took a while to get into that equilibrium state. So again, if I take it off screen, I have to wait a second for all those particles to die out. But then if I bring it on screen, see, it's filling in, right? So this was an important option to get on to all of these emitters, and they can all have their own they can all have their own activation offsets, is what I call them, where by default they're looking at the camera and they're saying if we're within 8 tiles, and that's 8 tiles in any direction, switch on. But if we want to, we can set that to be much larger. If we have one that takes a long time to reach equilibrium, we can set that to be 32 tiles or something like that. And this is the kind of thing that you would fine tune through level design and, you know, by thinking about how fast the player could move through a certain area. Because it's a whole different ball game. Like if this is my top speed, then, you know, we need, the offsets can be smaller. Whereas, you know, if I can run or I can slide along the ground, all of a sudden my offsets need to be larger in order to compensate for how fast the player might be moving, you know? But the nice thing, of course, is that if we deactivate them when they go off screen, then we're not wasting processing power, spawning a bunch of particles that we're never going to see, right? So it's the kind of thing that you would fine tune as you're tuning the levels and just making sure that the player can't ever catch the emitter while it's kicking on like that. There are a couple of other options as well, though. Here you can see the ancient letters being put to another use. I couldn't resist once I thought up the idea. Pretty cool. It goes to show what you can do if you just mess around. It was very easy to set that up, which is nice. That's what we're aiming for. You know, once we have an idea for something, we want to minimize the amount of time between having the idea and getting it on screen and tweaking it and stuff like that. So by default, emitter offsets work from the camera, but we can set it to care about something else instead. So the player character is here, and now if I walk under this overhang, the emitter kicks on. So there's another one which tests for collisions against the player character. And it's just one or the other, actually, which is a nice thing about how I've set it up. It's, again, all of these emitters are the same thing, right? They just have different options plugged into them. And I think I've done it in a fairly efficient way where it's not running a check against every single thing in the game or anything like that. It's just looking for the thing it cares about. And it's going to test against that. And if I'm there, spawn the particles. If I'm not, die out, right? Switch off. And by messing around with the activation offset, we can get all kinds of cool things to happen. So another thing, the activation is one thing, but also where we spawn is another thing. All of these things have been spawning so far. They've been spawning based on where the emitter is. So these dots here, they're spawning inside the emitter. The emitter is stretched to fill that square, whereas the kind of matrix things here there's an emitter that covers the 4 tiles at the bottom there, and they're just spawning at the top of that emitter and moving upwards, right? But they're all spawning based on where the emitter is. But there's no reason why we can't spawn where other things are instead. Now, this looks like crap because the player character is bright blue. I thought you all might like to see this blocky guy again, even though it's not really him. But you can imagine all kinds of different particles that we might spawn on the player character, right? We might have, like, they walk into an area and it's a magical area, and as a result they get this kind of magic effect on them or something like that, right? So we can spawn on the player character if we want to. We can spawn in an area only when the player character touches it. So anything inside this box touches it. I'll show you, and by the way, yeah, so by playing with the activation offsets, we can get really precise results. So this effect only happens when the player is touching the floor. So it's only on the very last pixel, if they're touching the floor, that it kicks on. Now there's a slight delay because the particle has a lifetime. Again, that's the kind of thing we can tweak. There's a slight delay about when they go away, right? But they only appear when we're actually touching the floor. So likewise, now this is the worst. This one looks the worst, I think, of all the effects. Again, I threw these sprites together very quickly, right? But we can do something like this as well. Like if the player touches the floor, maybe it becomes electrified or something like that, right? And we have these little things that appear on the floor. So the player touches the floor, we can spawn stuff on the floor. If the player touches the floor, we can spawn stuff on the player. We can spawn stuff, you know, around the player. We might, you know, something like this might be used for a save point or something. When you walk into a certain area, you get that thing that kind of lets you know, okay, this is something you can interact with or something like that, right? And this is a little effect I put together. Again, it's not going to look that good because the player is bright blue, but I really like this effect, in theory anyway. Again, a lot of these things can do with tweaking. You could tweak them forever, and I happily would, right? But I think this one is pretty cool already. It's kind of like imagining the player character getting scanned by some kind of AI entity or something like that. So we can get a thing which tracks the player and sits in front of them and scans them like this. Like it's a little scanner along the ceiling. And this actually shows that I think this is too complicated to explain in the video, but the X and Y coordinates of where we scan are decoupled from each other. So if I can try and explain this briefly, we're pulling the X coordinate from the player, but we're pulling the Y coordinate from the emitter. So the Y coordinate is the top of the emitter, which is, the emitter just fills this whole area, right? The Y coordinate is the top of the emitter, but the X coordinate is the player's position plus a little bit, so it's pushed forward. So the X and Y of these things are actually decoupled from each other, so we can get interesting things like this where we spawn something over the player character's head at a consistent height. And likewise, we could do that the other direction as well. Like say the player is moving upwards vertically through some tunnel, we could have a laser beam spawning on them horizontally or something instead, So all kinds of different things there on the emitter. Hopefully all that makes sense. I think I've stayed in here long enough. And there's still a bit more to show. Right. So on top of the player character or the emitter, there's a couple of other things we might care about as well, which is the camera. And again, just want to say, I threw these sprites together myself very quickly. I actually think they look pretty good. Especially considering how fast I did them and how bad an artist I am. But anyway, they're supposed to be leaves and little dust motes, I think of them. There's these little dust motes, there's way more of them in this room than you probably would put in a room. But if we were in a dusty room or something, you could imagine wanting to have a few of these little things moving around, or maybe spores or something like that, right? The leaves are spawning relative to the camera, which means that we're not spawning them outside the field of view. But like I said earlier, we can have different offsets on where we spawn stuff. So they spawn 32 tiles in each direction because they're very slow, right? It takes a long time for them to reach equilibrium, if that's the term. Maybe there's a term that I'm missing, but anyway. It takes a long time for them to reach equilibrium, so we want to spawn them very far aside on each side of the screen. Otherwise, I think maybe this was in the prior video, or I'm not sure, but otherwise we can end up with a kind of Truman Show effect, where as the camera moves, you're seeing that the rain is just being spawned outside the camera, or the leaves are being spawned just outside the camera, right? Just like that bit in the Truman Show where it rains over them, right? The illusion is broken if it's not done well enough. So those are spawning relative to the camera, and the dust motes are spawning relative to the room. Now I think the room, so they're just spawning anywhere in the room randomly. I think the room option is one that I would use very sparingly, especially because the project I'm currently working on, I think I want the rooms to be pretty big. So a room in Game Maker is, just like a single level, let's say. And then just like in Super Metroid, whenever you have to walk through a door, right? That's kind of what it is, right? Where the game has to reset and load some new stuff and it moves over, right? So I think for the project I'm currently on, I think I want the rooms to be pretty big. So I'd probably use this sparingly because it means that we're spawning stuff everywhere in the room. It's not efficient, right? But if we're only going to spawn a couple of particles here and there, maybe that's okay. And if the room is small, maybe that's okay. And it's a simple way to get it without having to worry about the camera offsets or anything else like that. Maybe there's some other reason why we might want to spawn stuff in the room. For example, if we had a room which was just, I don't know, you going up vertically or something like that, and it was thin, maybe you want something that just spawns something at the side of the room. I don't know. But it's good to have the option in there anyway. Yeah, so I think that covers most of the things about emitters. I probably forgot to say something. I don't know. That covers most of it, and it's on to shaders, right? Here we go, into the shaders. All right, the first shader, of course, is monochrome. This would be the first shader you would make for any kind of, like if you're testing out shaders, if you want to learn how to do shaders, first thing to do is just make a monochrome one, right? Not really very interesting, but I do want to point out, if you haven't noticed yet, there's actually already been several shaders in this video. First of all, the player character is a shader, but that barely even counts, right? Because it's very simple. I'm using a shader to hide Victor, right? But there's actually another shader that you've seen already if you were watching, and it'll be much more overt this time if you watch here, right? So there are shaders that work for room transitions. This was not something I could do before. Just moving between different rooms, right? I haven't shown that in the video yet. We have a thing here which triggers our room when we go off screen, and we can set different masks. So this is done based on a mask, and we can set different masks for how we want to move from one room to another, how we want to transition the screen between those two. So if I go back here, you may not have noticed it, but there's kind of like a brushstroke kind of thing going on between these rooms, right? And it can be anything we want. So that's basically done just by looking at an image. It's just a grayscale image which shows where the brush strokes or whatever they are, or where the blocks are, and it decides how we move as time advances, how we move from one room to another, how the screen changes. That's done through a shader. And it's important, this is an important thing to get working on top of all the other shader stuff I've done. I'll explain that in a minute, but it's nice that you can see the shader, the way the room transitions is not affected by the shader of the underlying room, which is important, right? We want it to sit over all the other shaders and sit on top of them and, yeah, be the final step, right? Okay. Here we have a kind of film grain thing going on. Not something I would actually use myself, but I just thought I'd try it out. I don't think it looks great, but hey, it's kind of interesting, right? And it was, I'm trying to understand how to get randomness into shaders, which is, you would think it would be easier than it is. There doesn't seem to be any kind of standardized way of doing randomness in shaders, which is unfortunate. But anyway, probably a result of how GPUs are set up. They're not really built, I suppose they're not really built to be random, right? They don't have a, I don't know enough about the hardware, but they're not a general purpose thing, which probably makes it harder to get randomness out of them. I don't know. But anyway, film grain, right? And there's another transition, kind of looks like a clock or something. Now this one is interesting. You may not even be aware that there's a shader happening here. This is one I'm kind of interested in myself. I have it hooked up to a key where I can press a button and it'll change. So I'll do that in a second. But it's a gradient map. If you're an artist, you might be familiar with this because there's an option for it on Photoshop, stuff like that. Where what it does is it looks at the luminance of each pixel and it substitutes a different color out for that brightness band, right? Now what's happening here is we're doing the shader, but we're mixing it in. So it only has a strength of something like 0.3 or maybe even 0.1 in this room. It's very subtle, right? So it's mixing in a little bit of red right now, I think. And I'm going to press the button to swap it out. I don't know how clearly this will come through, but if you watch closely, you'll see the color should change slightly on everything. See, now it's brighter red. That inverted the gradient. Now if I press it again, we can see it's kind of greenish. There's some more green, kind of bluish. I think that's yellow. And there's a couple of other weird effects that I have in there as well. Right. So I'll show you a more extreme version of this in a second, but one way I'm interested in using this is I think it might be useful to set up a kind of ambient feeling for each level. Let's say we have a level that takes place at sunset. Well, I can have the gradient map mix in a bit of orange with just a very slight strength to it, you know, like just a 0.1% of the color becomes that, you know, like it mixes it in at a different strength, and I can tweak the strength to whatever I want it to be. So we could get a little bit of orange in on everything, or likewise, if it's nighttime, we could get a little bit of blue in on the lighter colors and black in on the darker colors, or anything else. Say we walk into a bright room, maybe we put some white on there or something. I can try out a bunch of different stuff. I think this might add a little bit of texture to the game. Ideally, it would want to be something that you don't really notice consciously, you know, just something that's kind of there and kind of helps you pull you into whatever scene you're in. But I need to get an actual level up with some proper sprites before I see how effective that's going to be. But I'm interested in that one. And the cool thing about it is, by the way, on the back end, is that it's not a bunch of numbers, right? So every time I press this key, it's changing to a different gradient. It's not a bunch of numbers that I've written in specifically. It's actually looking up an image which has just a little gradient actually drawn on it, right? So we can see what the gradient is, and it's very easy to edit and get a nice feel for it straight away. It's less annoying to set up. So I don't think any of these shaders have been particularly impressive so far, but what's interesting is what comes next, and you'll see it here. All right, so everything has jumped up in complexity quite a lot here, right? Now here's the interesting thing, and here's where the bulk of the work went into here. This was the real kind of breakthrough cool thing about shaders that I got done during this time period. First of all, let's list off what's happening here. There's a film grain thing, which is kind of less strong than it was before because it's also being blurred, right? It's a Gaussian blur. It's got scan lines on it, and it's got a kind of weird flashbang effect, kind of like something you might see in a horror game or something, where there's an after image pulsing on the screen every once in a while that's being left behind. Yeah, so we've got at least... Oh, and there's the gradient map, of course, as well, right? So this is the gradient map again. I'm not sure if this is going to be... I should probably just give an epilepsy warning here. I don't know if it's going to be that bad, but let's try it out, right? So if I press my gradient map button, we're going to get different colors in here. All kinds of different colors, and we can do some pretty weird stuff. Oh, that looks pretty cool. I like that one. It's like an old TV. I don't think I've actually looked at this yet. I really like the way the fuzz looks on that as well. That's cool. That's pretty cool. That's horrible. So is that. These are just weird colors that I threw down at random just to see what would happen. And this is your Virtual Boy filter. Let's get back to the Game Boy, right? So there's the gradient map as well. So just to recap, scan lines, film grain, gradient map, Gaussian blur, and a kind of flashbang thing, right? Now, the interesting thing about this is that they are not done in one shader, right? They're not written together. They're not customized to work nicely with each other or anything like that. They are part of what I'm calling a shader chain, right? So what's happening here is, and this is a benefit of using pixelated graphics, because most of the time, all of the time in fact, right, the game is not being rendered at 1080p. So what you're seeing right now is 1080p, of course, right? But most of the time, the game is being rendered at 640 by 360, which is an integer scale of 720p and 1080p, right? It's just another step down, right, from those. And what that means is that when we run a shader on something, it doesn't actually have to crunch through a lot of stuff. It's 9 times fewer pixels than a 1080p image. So we can actually run... There's a bit of cost involved in swapping shader, of course, right? Probably a fairly hefty cost. But if we just look at it pixel by pixel, we could run 9 shaders for the cost of 1 shader on a 1080p image. So the game only scales up at the very last step. Every other step before then is run on the lower scale image, the pixelated image at the actual pixel scale that we're running the game at, right? And what this means is that we can create a chain of shaders just by doing them back to back, just by, you know, flipping between them. We just do one shader, then we set it up so we can do the next one over that one, and the next one over that one, and the next one over that one. And as a result, you can get a bunch of different shaders together. Now, I want to clarify something here and say that this isn't the best way to do this, right? Because there is a performance cost involved with drawing the shader several times. Some of these things could be combined with each other. We could write one shader that combines the gradient map with the scan line and the blur, right? Or the film grain, let's say. So we get the film grain, the gradient map, the scan lines. We could get all of those on one shader, and that way we're only doing one pass over all the pixels, which will save us from two whole passes of a shader, right? Which is a pretty significant save. But also, it's important to recognize that in this day and age, doing a shader on a 640 by 360 image is not the end of the world, right? Doing an extra pass on that is not the end of the world. So it means that we can mess around with different shaders and get a bunch of different effects without having to write a custom shader that does several different things at once. We don't need a film grain, gradient map, flashbang shader. We can just do those 3 shaders individually and get them to work together that way. And then maybe if, through that kind of experimentation, if the desired effect is good enough that we want to use it in a bunch of different places, then maybe we go and write a shader for that to make that performance gain. But I don't think that's really necessary. I don't think that's really going to be necessary most of the time. If this is something that's constrained to one room or something, there's not really going to be much harm in doing it this way. So the important thing here is that these shaders all work nicely with each other. And actually by changing the order that they're run in, we can get slightly different effects. Like the film grain could be more pronounced if it ran at the end or the start. I forget which, at the end probably. So that it's sitting over the rest of the image, Whereas now it's being done and then it's being blurred, We can kind of tweak things that way as well. And all this is just taking the shader, dragging it into the room and just making it part of that chain of shaders. And importantly as well, on top of that, the room transition shader is unaffected, right? It runs on top of all these things without taking anything from them. So it's kind of a separate step which is done last on top of everything else. Yeah, so I don't know what else to say. It'd be cool to do some more shaders. There's definitely a lot more I want to do in that area, but you can see how chaining them together, I can get a bunch of different cool effects all at the same time without any worries. And I don't know if this is really going to see any use, but I could imagine wanting to have, like, especially in the project I'm working on now, I don't know if these are going to see much use. I think I could maybe imagine using them here and there, but it would be pretty sparse. But I could also imagine having an option in the options menu to just allow the player to turn on a bunch of these things just for the hell of it, and see what happens, and then we can have all these as individual options in the option menu, right? But not the flashbang one. That's just, I don't know where this idea came from, but I just thought it's kind of like a horror game thing or something. You get this pulse on your screen. Like if you have a boss in the next room, you have like a, to show that there's something out there, like you've got a big electromagnet pulsing and it's messing up your head or something like that. Yeah, so yeah, I'm rambling. I don't know what else to say, but I'm very happy with how this came out. I think it's cool that we can get a bunch of them together. There's no reason why we can't have 10 if we want to. And while the performance is not going to be ideal... Oh yeah, one more thing I should say is that actually it's set up in a nice way that the blur is already a 2-pass shader, because the best way to do a blur is to do it horizontally and then vertically, at least to my knowledge anyway. You want to do it horizontally, then vertically. So the blur already uses 2 passes, but even though it uses 2 passes, it slots into the chain very nicely, because I just have a little function I can run that just flips that around for me and does it, right? So even if we have a shader which uses 2 passes, or we have a shader which has its own surface, that's another thing. This flashbang surface, this is why it's good for testing actually, yeah, is it has to keep its own surface and remember what was on screen. Like if I'm moving when the flashbang goes off, you see how I'm still in that state, right? It's not like it's catching up every frame or something like that. It stays the way it was. And yeah, I don't know how to put it, but it basically has its own surface which it needs to draw, and it can do that as well and still be part of the shader chain, which is cool. I think that covers everything. The funny thing about doing this is that when I started out, or not when I started out, but say at the start of this month, and I was thinking, okay, by the end of the month, I'd like to talk about emitters and shaders probably. The shaders were in a better place than the emitters, and then I went back and messed with the emitters, and then I did some more on the shaders, and It's just funny how you kind of flip-flop between them. Because I've been working on emitters for the past while, and up until then, I think shaders, this was the more impressive thing to me, but now I think the emitters are probably stealing the show here, and I'm trying to think, how do I get the shaders back so that they're as good as the emitters, you know? But yeah, you could bounce around these things forever. Even now, there's a whole bunch of stuff that I want to do, particularly on the emitters. There's still stuff I want to do. Like, there's no way of just spawning particles when a character moves, which I think would be good. You can imagine if you're underwater, you know, only spawning bubbles as something moves around. That could be very useful. But anyway, yeah, I think that covers... Yeah, that covers enough. I'm just rambling at this point. So, thanks for tuning in. And, yeah, nothing more to say. I don't know. I don't know when I'll do the next update. But I'll talk to you again whenever I have something else interesting to show. Hopefully this was interesting. I'll see you next time. Bye-bye, everybody.